to another A-Level Computer Science video with me, Mr Goff, for MrGoff.com. This video will focus on Dijkstra's shortest path algorithm. Dijkstra's shortest path algorithm is an optimization algorithm designed to find the shortest path between one node and every other node in a weighted graph. The algorithm uses a priority queue containing the nodes of the graph, with the priority being the distance to the node. To begin with, it is 0 from the first node to itself and an unknown distance to other nodes, represented initially by infinity. At each node, we update the distance to its neighbours, taking account of any distance already travelled to this node. The next node is the node at the head of the priority queue, that is, the one that currently has the lowest distance from the original node. Let's take a look at an example. In our example, Dijkstra's algorithm will be used to calculate the shortest distance from node A to every other node in our graph. We start by giving node A a value of 0, since it is 0 to travel from node A to itself. For all other nodes, we start with an initial value of infinity. A is at the head of our priority queue, so we remove it from the queue and we visit node A. From here, we're able to update the paths to C and B, which are 3 and 8. As C has the shortest path, it comes to the front of our priority queue. C is popped off the priority queue and we visit node C. We can now update values for nodes D and E as being equal to the distance from A to C and then C to D, and A to C and then C to E. When we check, from A to C then C to B is actually shorter than from A to B, so we need to update the shortest distance to node B from 8 to 7. Had this path been longer, it would stay at its original value. It keeps its shortest path. B is then removed from the priority queue and we visit node B. At node B, we can see that there's now a faster path to get to node E, so we update the shortest distance to node E to be 17. D is removed from the priority queue and we visit node D. Here we can see that if we go via A, C and D and then on to E, that we have a shorter path to E of 16, so we update E's shortest path to 16. Then we pop E off of our priority queue and we visit node E. There's no new places to visit, so there's nothing to update. Each time we have popped a node off the stack, it has had its shortest distance. Final shortest distances are 0 from A to itself, 7 from A to B, 3 from A to C, 9 from A to D, and 16 from A to E. Dijkstra's shortest path algorithm is useful in areas such as finding the shortest distance between two places on a map and routing protocols for networks. Dijkstra's algorithm finds the best path from a source node to all locations, whereas an A-star algorithm is trying to find the fastest route to a specific target node. Dijkstra's algorithm tracks one cost, which is the value on vertices connecting nodes, but A-star algorithms also consider the approximate distance from each node to the target node. The total cost of a node, therefore, is the cost from the source node to the current node, plus the approximate cost from the current node to the target node. The total cost from the current node to the target node is not known, so it must be approximated using a heuristic method. An heuristic method is a method that is good enough while not perfect. There are many ways to approximate the distance to the target, but the method used should never overestimate the distance. That is, the real distance should be equal to or greater than that predicted by the heuristic method. A-star algorithms are commonly used in GPS systems tracking fastest routes, and to allow game sprites to navigate a map towards a specific target. The image here is a still from a video from the rather excellent Kids Can Code website, where you can see a video where they talk through a practical implementation of both Dijkstra's shortest path algorithm and A-star algorithms in creating Pygame games. I highly recommend you go and watch these videos. That brings us to the end of this video on Dijkstra's shortest path algorithm. Join me again for another new video soon. Use the resources at mrgoff.com to help you revise computer science. And until next time, it's bye for now.